This is Ethernet KE, and today I'm going to demonstrate how to configure EtherChannels. EtherChannels are very important because they allow us to utilize fully the bandwidth that comes with the switch. For example, if you have a 2960 switch from Cisco that has 24 ports and maybe you're using two ports only, you can bundle ports to become like one link. So then you can be able to utilize the bandwidth. If one port is sending a lot of data and the others are idle, then it is important to bundle them because they can share the bandwidth. It's like they share and become like one link. So when you send data, you should go through all the links, all the physical ports, or the physical links, and it will assume that it is using one link. So that is what EtherChannel does mainly. So welcome, and let's look at this. Packet Tracer, it is based on Packet Tracer in CCNA 2 version 7, the activity 4.2.1.3. The objectives are to configure basic switch settings, configure an EtherChannel with Cisco PAgP, that's port aggregation protocol, and then we configure an 802.3 AD LACP, which is link aggregation control protocol, EtherChannel, and then we configure a redundant EtherChannel link. The background: 3 switches have just been installed. There are redundant uplinks between the switches. Usually one of these links could be used. Otherwise, a bridging loop might occur. However, using only one link utilizes only half of the available bandwidth. EtherChannel allows up to 8 redundant links to be bundled together, so you cannot bundle more than 8 links into one logical link. In this lab, you will configure PAgP, which is a Cisco EtherChannel protocol, and a link aggregation control protocol, LACP, which is an IEEE 802.3 AD open standard version of EtherChannel. So part 1, we configure basic switch settings. Configure basic switch parameters. Assign each switch a host name according to the topology diagram. We go to S1, enable config T, and then we give it a host name of S1. The same as that, we do the same to S2, enable config T, host name S2, and S3, enable config T, host name as S3. We then configure all required ports as trunks depending on the connections between devices. If the ports are configured with dynamic auto mode and you do not set the mode of the ports to trunk, then the links do not form trunks and they remain as access ports. And remember, these, we are bundling ports. We are bundling links to act like one link. So it has to be a trunk because each link could be configured in a different VLAN from the other. So we have to create it as a trunk so that it can be able to carry traffic from all the trunks that are configured. The default mode on Cisco 2960 switch is dynamic auto. So we have to configure all ports as trunks. So if you check S1, gigabit 01 and 02, fast Ethernet 21 and 22 are all the links that we are going to use in the EtherChannel, and these are the links that we want to configure as these ports. We are going to configure them as trunks. So for S1, we go to interface, range, gigabit 0/1 to 2, and then fast Ethernet 0/21 to 22. 0/21 to 22, we configure them as trunk port, switch port mode trunk. For S2, we have gigabit 01 and 02, and fast Ethernet 23 and fast Ethernet 24 as the ports that we want to configure as trunks. Interface range, we go to gigabit 0/1 to 2 and fast Ethernet 0/23 to 24. Switch port mode trunk. Same in S3. Interface range, we have fast Ethernet 21, fast Ethernet 22, fast Ethernet 23, and fast Ethernet 24 are the links or are the ports that we want to configure as trunks. So fast Ethernet 0/21 to 24, switch port mode trunk. We go to the second part, configure an EtherChannel with Cisco PAgP. When configuring EtherChannels, it is recommended to shut down the physical ports being grouped on both devices before configuring them into channel groups. So all of these ports, we're going to switch them off or we're going to shut them down. Otherwise, the EtherChannel misconfig guard may place these ports into error disabled state. The ports and port channels can be re-enabled after EtherChannel is configured. So we first shut them down to avoid the EtherChannel misconfig guard from placing them into the error mode or error disabled state. So S1, we are already in the interface range. We shut them down. Remember to always copy run configuration to start configuration to save the configuration. For the S2, we are still in the range, so we just shut them down and then we copy running config to startup config. Same as S3, we are on the range, interface range. We shut them down. It's important to keep saving the configuration. Now we've switched them off. The ports and port channels can be re-enabled after either channel is configured. Step 1, we configure port channel 1. The first EtherChannel created for this activity aggregates ports fast Ethernet 22 and 21 between S1 and S3 here. So we are going to aggregate them. Use the show interfaces trunk command to ensure that you have an active trunk link for those two links. So let's see, we use S1. We show interfaces trunk. We've switched them off, so it's not the right time to show. So we go to configuring the port channel. On both switches, add ports fast Ethernet 21 and fast Ethernet 22 to port channel 1 with the channel group 1 mode desirable command. The mode desirable option enables the switch to actively negotiate to form PAgP. It is important to note this, that for you to configure a link as PAgP and either channel as PAgP, you use mode desirable. You use desirable mode. So go to S1. From S1 config T, we go to the interface range, first Ethernet 0/21 to 22. Now we are going to add this into a port channel 1. So we say channel group 1, that one represent, this is port channel 1, mode desirable for PAgP, creating. Configure the logical interface on both switches. So we're going to S3 as well. Configure terminal interface range. First Ethernet 0/20, the link between S1 and S3, 21 to 22. Then we add that to the channel group 1 with the mode desirable for PAgP. Remember, now we have these two links configured as in the one channel. So the next part, we configure the logical interface to become a trunk by first entering the interface port channel 1 command and then switch port mode as trunk. Remember, now we've created a new link which is now an EtherChannel link. We have to make it now a trunk, as we said earlier. We have to make it a trunk so that it can be able to carry the traffic from all the VLANs that are allowed in the physical links. So we can exit here. We go to the interface port channel 1 and now we make it a trunk link. On S3 we do the same. We go to the interface port channel 1 and we make it a trunk. The Cisco packet tracer doesn't, in this packet tracer, it doesn't grade making the switch port a trunk. It doesn't, for the port channel as well. Now we have created that. So verify port channel 1. Issue the show EtherChannel summary command to verify that EtherChannel is working on both switches. This command displays the type of EtherChannel, the port utilized, and port states. Show EtherChannel summary. If you look at from S1, now the show command for EtherChannel summary shows us that first Ethernet 21 and 22 are on PAgP, are using PAgP protocol, that is port aggregation protocol, and they're in port channel 1. And when we check from S3, show EtherChannel summary. In the port channel 1, we have PAgP on first Ethernet 0/21 here and 0/22 here. And if you check, they are all down because we've not activated the port, so they are down. They are administratively down. That's why we have a D here for down. That's it for now. If the EtherChannel does not come up, shut down the physical interfaces on both ends of the EtherChannel and then bring them back up again. This involves using the shutdown command on those interfaces followed by a no shutdown command. Now we can bring them up. Config T interface range. First Ethernet 21 to 22 for S1, and then we give the command no shutdown, the same as S3. Configure terminal interface range first then 21 to 22, and then we issue the command shutdown. Now if we go now check the status of the ports, you can see now they're in the port channel. They're now in the port channel, they're not down, they're in the port channel. Show EtherChannel summary. You can see the interfaces now are in the port channel. The show interfaces trunk and show spanning tree commands also show the port channel as one logical link. Let's issue show interfaces trunk. Show interfaces trunk. You can see the port channel 1 is given as just one link, one logical link. And if we show spanning tree, show spanning tree, we get the same. The port channel is 1. It's only what it's treated as one interface or one link, which is port channel 1. Now we go to part 3. Part 3 is configure an 802.3 AD LACP the channel. We are going to configure that in port channel 2. In 2000, the IEEE released 802.3 AD, which is an open standard version of EtherChannel. Using the previous commands, configure the link between S1 and S2 on ports gigabit 01 and 02 as LACP EtherChannel. You must use a different port channel number. We used port channel number 1, and now we're going to use port channel number 2 for port channel 2 for the next EtherChannel. Because you already used that in the previous step, we're not going to use one. To configure a port channel as LACP, use the interface configuration mode, channel group number, and then mode active. Active here is something important to note. If you use the mode as active, you configure the links as LACP, link aggregation control protocol, not PAgP. For PAgP, we saw it is desirable. Active mode indicates that the switch actively tries to negotiate that link as LACP as opposed to PAgP. Now we go to port channel 2. We are going to aggregate these two ports and these two ports. Configure terminal. We go to interface range on S1. Gigabit 0/1 to 2. Interface range gigabit 0/1 to 2, and now we give this to the channel group. Channel group 2 and mode active. We go and do the same to S2. On S2, enable configure terminal. We go to interface range gigabit 0/1 to 2, and then we add them to the channel group 2, to the port channel 2. Channel group 2, mode active. Step 2, we verify port channel 2 status. We use the show commands from part 1 and part 2 to part 1 step 2 to verify the status of port channel. Look for the protocol used in each. So from here we can end. Let's first save, copy running to startup configuration. We show interfaces we show either channel summary, and you can see we have the ports, either channel ports or port channel 2 as an LACP. It is using the LACP as a protocol, and you can see the status of the ports are still down because they are on shutdown. We shutted them down. So then we go to, that is for S2. Let's see from S1. We show either channel summary. You can see now we have from S2 we have we have the port channel 1 and port channel 2, and port channel 1 is the one that we configured with PAgP, and now port channel 2 we've configured it on LACP, and you can see the status now here is down for the ports. We can now bring them to life. Configure terminal, interface range gigabit through that, and then we issue the no shutdown command. The same as S2, configure terminal, interface range gigabit 01 to 2, and then we issue the command no shutdown. We can we can fast forward time. Now we are going to configure a redundant either channel link. Configure port channel 3. Now we are here. We are configuring port channel 3. There are various ways to enter the channel group number mode. Interface range, channel group 3 mode. You can use active or desirable or passive. On switch S2, we're going to add fast Ethernet 023 to 024 to port channel 3 with the channel group 3 mode passive command. The passive now here option indicates that you want the switch to use LACP only if another LACP device is detected. If on the other end it's an LACP device, or the device has been configured as LACP, then passive will make these ports LACP as well. Statically configure port channel 3 as a trunk interface. So even this one, I think we have not configured this as port channel as trunk. We exit interface port channel 2, and we configure it as the switch port mode trunk. The same on S2. Exit interface port channel 2. We configure it as a trunk. So here we come to S2. We go to interface range, fast Ethernet 23 0/23 to 24. We add them to the channel group 3. You're going to use 3. Channel group 3 mode passive for them to negotiate with the other LACP to become LACP if the other end is LACP. We can exit. Now we have the port channel 3. We go to the interface port channel 3 and add it as a trunk, configure it as a trunk port, trunk link. We go to the other side to S3, and fast Ethernet 23 and 24 are the port channel. We are going to add them to port channel 3. Configure terminal, interface range, fast Ethernet 0/23 to 24, and we add them to the channel group 3 with a mode passive. we are going to use mode active for S3 because we want it to be statically LACP, so that this the port where we configure it as a passive, it will become LACP because of the other side. So let's see, we have to make these active. Now we can exit and make it a so interface port channel 3, and we configure it as a trunk port or a trunk link. From here now we can now bring up the ports. Now we can issue the no shut command, interface range first Ethernet 0/23 to 24, and then no shutdown. At this moment we can save the copy running start. And also from here we see to the configuration, and we go to configure terminal. We want now to activate the ports because we switched them off or we shut them down. Interface range first Ethernet 0/23 to 24, and then we issue the no shutdown command. From there now we have all the port channels now are configured and all the links are up, but there are a few things that we need to check. Let's first verify port channel 3, because we can see it's like we have already finished our configuration for the Ether channels. We configured port channel 1, port channel 2 and port channel 3, but still we are at 99% the completion. Now we get to understand why. Use the show commands from part 1 step 2 to verify the status of port channel 3. We check from S2 and then we show EtherChannel summary. You can see already the port channel 3 has been activated as an LACP because the other end we've configured it as LACP. So it has negotiated and become an LACP port. Then from there we can check from S3, show EtherChannel summary, port channel 3 again, and you can see they are now up, not down. The port is up, and you can see it is an LACP as we configured it. And we are told that port channel 2 is not operative because spanning tree protocol, the STP, placed some ports into blocking mode. Unfortunately, these ports were gigabit ports. To restore these ports, configure S1 to be primary route for VLAN 1 or set the priority to be this. We add the command spanning tree VLAN 1 root primary, and therefore now we have if you fast forward the timing, now that is 100% completion. Thank you so much. I hope you are learning in terms of configuration and understanding the concept of EtherChannel. I hope to see you in the next video. Thank you.